What if a planet, a world like our own, was hurtling through space, aimlessly wandering the cosmos? And what if its path intersected with ours? Imagine a world, a planet, drifting alone through the vast, dark expanse of the cosmos. A world cast out from its solar system, wandering aimlessly, a celestial orphan. These are rogue planets, and they could pose a threat to our own existence. How do these cosmic nomads come to be? One theory suggests they're ejected from their home systems during the tumultuous birth of stars and planets. Gravitational tugs of war can fling these planetary bodies into the interstellar void. Another possibility is that they're captured from other star systems, snatched away by the gravitational pull of a passing star. Giant planets like Jupiter are the big kids on the block, and sometimes they can accidentally knock smaller planets out of their orbits. These poor, ejected planets are like cosmic orphans, adrift in the vastness of space. Out there somewhere, within the vastness of space, a chaotic solar system, a swirling mass of gas and dust is coming to be. As planets begin to form, gravitational interactions can fling these nascent worlds out of their orbits. A gravitational tug-of-war between a massive gas giant like Jupiter and a smaller, less fortunate planet can result in the smaller planet being ejected into the interstellar void. Another possibility is that rogue planets are captured from other star systems. As stars pass close to each other, their gravitational influence can pull planets from one system to another. These captured planets, now far from their original homes, become rogue planets, forever wandering the cosmos. Much like a speeding car driving on the wrong side of the road, these rogue planets are destined for eventual disaster. Imagine a cosmic game of planetary billiards. As stars and planets form, a chaotic dance of gravity unfolds. Massive gas giants like Jupiter can act as celestial bullies, flinging smaller, less fortunate planets out of their solar systems. These cosmic orphans, ejected from their homes, become rogue planets, adrift in the interstellar void. But there's another, more sinister way these rogue planets can emerge. Like cosmic pirates, they can be stolen from other star systems. As stars pass close to each other, a gravitational tug-of-war can ensue. The weaker star, unable to hold onto its planets, can lose them to the stronger one. These captured planets, now far from their original homes, become rogue planets, forever wandering the cosmos. Imagine a vast cosmic ocean, teeming with untold numbers of celestial wanderers. These are rogue planets, worlds cast adrift, floating aimlessly through the galaxy. Scientists estimate that there could be trillions of them, a number so mind-boggling it's like trying to count all the grains of sand on every beach on Earth, and then multiply that number by 1 billion. It's like a hidden universe, a parallel reality filled with planets that never had a home star. Each one, a silent witness to the cosmic ballet of creation and destruction. This staggering number is a testament to the sheer scale of our galaxy and the countless mysteries it still holds. These rogue planets are the cosmic orphans, the interstellar nomads, the forgotten worlds. Yet they are a crucial part of the universe's story, reminding us of the vastness and the mystery of the cosmos. Now let's bring this cosmic discussion a little closer to home. Could one of these rogue planets, these interstellar wanderers, pose a threat to our own planet Earth? While the chances are slim, the potential consequences are terrifying. Imagine a planet perhaps many times the size of Earth, barreling through space at incredible speeds. If one of these cosmic giants were to enter our solar system, it could wreak havoc on the delicate balance of our celestial neighborhood. It could knock planets out of their orbits, or in the worst-case scenario, collide with Earth itself, an event that would be catastrophic for all life on our planet. If a rogue planet were to collide with Earth, the consequences would be absolutely devastating. The sheer force of the impact would be unimaginable, shattering our planet like a fragile glass ball. A colossal fireball would engulf the Earth, incinerating everything in its path. The heat would be intense enough to melt rock and vaporize oceans. As devastating and cataclysmic as this may sound, this is only the beginning. The debris from the collision would be flung into space, forming a cloud of dust and rock that would block out the sun. This would plunge the Earth into a long, dark winter, freezing the planet and ending almost all remaining life that was left following the initial impact. The once vibrant Earth would become a desolate wasteland, a barren husk of its former self. the delicate balance of life that has evolved over billions of years would be shattered. Ecosystems would collapse and species would go extinct. The Earth, a sanctuary for countless forms of life, would become a silent tomb. It's a sobering thought, but it highlights the fragility of our planet and the importance of protecting it. While the idea of a rogue planet hurtling towards Earth might make for a thrilling science fiction plot, the reality is far less dramatic. The vastness of space ensures that such a catastrophic event is incredibly unlikely. Our solar system is a well-established cosmic neighborhood, with planets orbiting the sun in stable paths. A rogue planet, a solitary wanderer, would need to intersect this well-ordered system to pose a threat. The chances of such an intersection are incredibly slim, given the immense distances between celestial bodies. Moreover, our solar system's gravitational forces are powerful enough to influence the trajectory of any incoming object. If a rogue planet were to enter our solar system, it's more likely to be captured by the gravity of a giant planet like Jupiter or Saturn, rather than colliding with Earth. While the possibility of a rogue planet collision can't be entirely dismissed, it remains a highly improbable scenario. The vastness of space and the delicate balance of our solar system offer us a significant degree of protection from such cosmic threats. But fear not, for humanity isn't sitting idly by. A new generation of astronomers is on the hunt for these cosmic threats, armed with a powerful tool, microlensing. Imagine a cosmic mirage. When a rogue planet passes in front of a distant star, its gravity bends the starlight, creating a temporary brightening effect. It's like a cosmic magnifying glass, revealing the presence of these invisible wanderers. While this technique is still relatively new, it's rapidly evolving. With each passing year, we're learning more and more about these mysterious objects. As we peer deeper into the cosmos, we're uncovering the secrets of the universe, one rogue planet at a time. So while rogue planets might sound like something from a sci-fi movie, they're a very real part of our universe. They're the cosmic orphans, the interstellar nomads, the forgotten worlds, and yet they play a crucial role in the grand cosmic story. The universe is a place of both beauty and danger. Rogue planets are a testament to the chaotic nature of the cosmos. As we learn more about these celestial wanderers, we gain a deeper appreciation for the delicate balance of our own solar system. Let us cherish our planet and work to protect it for generations to come. What other secrets does the universe hold? What other challenges might we face as we continue to explore the cosmos?
In 2007, a team of astronomers led by Dr. Duncan Lorimer detected an unusual high-energy burst of radio waves from a galaxy 3 billion light-years away. Known as the Lorimer Burst, this fast radio burst, or FRB, was the first of its kind to be discovered. This was huge. The signal was unlike any other cosmic event ever recorded, as it was much more powerful than typical radio waves from stars, and scientists could not explain its origin. That's the spooky part. Where did this come from? The burst lasted only a few milliseconds, but its intensity led to wild speculations, including theories that it could be the result of a collapsing neutron star, or even, you guessed it, extraterrestrial activity. Now, despite ongoing research, no one's been able to pinpoint its exact cause or location, keeping the mystery alive. The WOW signal. On August 15th, 1977, radio astronomer Dr. Jerry Ehman was reviewing data from the Big Ear Radio Telescope at Ohio State University, when all of a sudden he comes across a peculiar signal. Now, the signal was a sharp, intense burst of radio waves that lasted 72 seconds. Unlike anything the telescope has ever picked up before. Now, Ehman was so shocked by the anomaly that he circled the signal on the printout and wrote "wow" right next to it. Now, despite extensive follow-up observations, the signal was never detected again, leading some to speculate that it was a potential communication from extraterrestrial civilizations. The WOW signal remains one of the most famous and also baffling discoveries in the search for alien life, as no natural source has ever been identified. Fast radio bursts. Fast radio bursts, or FRBs as I mentioned earlier, are one of the most mysterious phenomena discovered in recent years. It was first detected in 2007, so it's quite recent. Now, these brief but incredibly powerful bursts of radio energy only last milliseconds and originate from deep space, somewhere out there. Now, what makes FRBs particularly perplexing is their high energy, suggesting that they come from some extremely powerful cosmic event, such as a collapsing star or a neutron-star merger. However, some scientists speculate they could also be a form of communication from alien life. Now, given the peculiar and unexplained nature nature of these signals, it's hard to say which is which. As more FRBs are discovered, with several repeating signals adding to the intrigue, they continue to challenge our understanding of the universe. Where are these? Where do they come from? Will we ever find out? The galactic plane signal. In 2015, astronomers working with NASA's Jet Propulsion Laboratory detected a strange and unexplained signal coming from the galactic plane area of the Milky Way, containing many of our galaxy's stars. Now, the signal, which was highly concentrated and unusually strong, was unlike typical cosmic radio emissions, leaving experts to consider, could this be a form of communication from an advanced alien species? While most believe the signal was a natural occurrence, like a stellar flare or interference from a satellite, something along those sorts, the unusual nature of the emission has sparked ongoing speculation about the potential for intelligent life beyond our planet. Now, until further investigation proves clarity, the galactic plane signal remains a massive enigma. The perplexing signal from Proxima Centauri. In 2019, astronomers working with the Breakthrough Listen initiative, they detected a peculiar and repetitive radio signal emanating from Proxima Centauri, our closest neighboring star system, only 4 light years away. I say only 4 light years as if that's close. It's not at all. The signal, which was narrowband and unlike any typical cosmic noise, was initially exciting because of the possibility that it could be a sign of alien life. Now, Proxima Centauri is known to have an Earth-like planet in its habitable zone, which only increases the intrigue. Could it be them? Are these our neighbors? Neighbors from far away? While the signal was ultimately dismissed as interference from Earth-based equipment or other natural sources, the repeating nature of the signal really raises questions about its true origin. The discovery added to this growing list of unexplained signals from space, keeping the door open to the possibility that we are not alone in the universe. The blip from Kepler Space Telescope. In 2011, NASA's Kepler Space Telescope, which was tasked with searching for exoplanets, they recorded a strange signal that scientists dubbed the Kepler blip. Now, the signal, which lasted for a few days, was unlike anything observed in the behavior of stars ever before. Its unusual characteristics led some to propose that it might have been caused by an alien megastructure, such as a Dyson sphere, which could theoretically harness the energy of a star. Down here on Earth, we only have Dyson vacuums, so maybe we'll get there one day. While the leading explanation for the signal was that it was caused by a cloud of dust or an unforeseen stellar phenomenon, the brief and unexplainable nature of the blip has many speculating. The Kepler blip sparked imaginations and of course fueled further interest in the idea that we might one day find evidence of this advanced extraterrestrial technology that we've been hinted at this whole time. Even if it's just a faint signal among the stars, we need something. The BLC-1 signal. In 2020, astronomers working with the Breakthrough Listen initiative, they discovered an intriguing signal coming from the direction of Proxima Centauri, a star system close to Earth. Now, the signal, known as BLC-1, was an unexpected narrowband radio emission that had all the characteristics of a potential technological signal. While it's much too early to conclude its origin, and most experts suggest it could be radio interference, it could be, the proximity of Proxima Centauri to Earth makes it pretty exciting. Proxima Centauri is known to have a planet in the habitable zone, which I mentioned, which of course only adds to the speculation about this potential for other alien life. The signal's discovery continues to captivate both scientists and enthusiasts alike. The pulsar signal from the outer solar system. In 2018, a strange signal that resembled the rapid pulses of a pulsar was detected by the Arecibo Observatory. Now, the signal came from beyond our solar system, as many of these do, and while its source was unknown, its characteristics pointed to something that wasn't just random noise this time. The pulsar-like signal repeated itself in a pattern, but it did not match the typical behavior of a pulsar. Given its regularity and unfamiliar characteristics, some researchers speculated that the signal could be evidence of a new kind of astronomical phenomenon. While the exact cause was never confirmed per se, the signal was intriguing enough to prompt further investigations and theories about its origins, ranging from astrophysical objects to, you guessed it, potential alien technology. The Arecibo message echo. In 1974, scientists used that same Arecibo radio telescope to send a deliberate message towards the globular star cluster M13. This time we're sending the message out. Question is, did anyone receive it? The Arecibo message, as it was called, was designed to be a beacon that could one day be received by extraterrestrial life. At some point, millions of light years away, in 2001, another mysterious radio signal was detected from the same direction near the same location that the message was sent. Although scientists quickly dismissed it as a natural phenomenon, the eerie coincidence sparked questions. Was this the first response from an alien species, or was it just an incredible case of interstellar coincidence? This odd signal remains an unsolved mystery, leaving us to wonder if there might be someone out there who actually received our message. We come in peace. I promise we come in peace. Please don't abduct us. The S-band mystery. In 2001, a mysterious and powerful radio burst was detected in the S-band frequency by NASA's Deep Space Network. Now, the signal came from an unknown source, and this time it lasted for 30 minutes. The strange thing about the signal is that it was repeated in a rhythmic pattern, and scientists scientists had trouble identifying the exact cause. Most believe it's a form of interference from Earth-based sources or an artifact from the satellite network, but others, like me, wonder if it could be something more intriguing, like say signs from an extraterrestrial civilization. That would be something. To finally get a response after this many years, we're here, we're ready for you. Despite years of analysis, the S-band mystery has never been fully explained, only adding to this growing list of unexplained radio signals from space.
For centuries, the cosmos have whispered secrets, beckoning the brave and the curious. But as the mid-20th century unfolded, a pivotal question emerged. Could we break free from Earth's grasp and journey into the unknown expanse above? And if so, who or what would take that monumental first step? The year was 1949. The world, still healing from the scars of World War II, found itself in the throes of a new kind of tension, the Cold War. Amidst this backdrop, the United States embarked on a daring endeavor. Scientists, driven by both ambition and necessity, selected a rhesus monkey named Albert II for an unprecedented mission. With gentle eyes reflecting innocence, Albert II was secured inside the cramped confines of a V-2 rocket. The goal: to understand how a living organism would react to the rigors of space travel, particularly the exposure to cosmic radiation and the physiological stresses of launch and re-entry. As the rocket's engines ignited, flames and smoke erupted, propelling Albert II toward the heavens. Reaching an altitude of 83 miles, he became the first monkey to cross into space. Under anesthesia to ease his journey, Albert II carried with him the hopes of a nation eager to conquer the final frontier. But triumph turned to tragedy when a parachute failure led to his death upon re-entry. Did his sacrifice weigh heavily on the minds of those who sent him skyward, or did it strengthen their resolve to push the boundaries of human achievement? The data gleaned from Albert II's flight was invaluable, laying the groundwork for future missions. His brief voyage, though ending in loss, marked a significant stride in humanity's quest to touch the stars. It posed a profound question. At what cost do we pursue progress? Half a world away, the Soviet Union watched intently, determined not to be eclipsed in the race to space. In the bustling streets of Moscow, a stray dog named Laika roamed, unaware of the destiny that awaited her. Chosen for her hardiness and calm demeanor, Laika was selected to become the first living creature to orbit Earth. On November 3, 1957, as Sputnik 2 thundered into the sky, the world held its breath. Could Laika survive the immense G-forces, the isolation, the unknown perils of space? The mission was as much a political statement as it was a scientific endeavor, a demonstration of Soviet prowess. Yet behind the grand spectacle lay a somber truth. There was no plan for Laika's return. Initial reports lauded her as a hero who survived for days, but the reality was far more tragic. Due to a malfunction in the spacecraft's thermal insulation, Laika perished from overheating just hours into the flight. "We shouldn't have done it," lamented Oleg Gazenko, one of the leading scientists. "Not because the data wasn't useful, but because we did not learn enough to justify the death of the dog." Laika's story ignited global debates about the ethics of using animals in such high-risk experiments. It forced humanity to confront the moral implications of its relentless pursuit of knowledge. Undeterred, the Soviets pressed forward. In July 1958, two more dogs, Lisichka and Chaika, were readied for a mission critical to the future of human spaceflight. Their objective was to test ejection seats and life support systems, technologies vital for the safety of cosmonauts. As their rocket ascended, hope soared with it. But fate intervened when an explosion just 28 seconds after liftoff claimed their lives. Was this a sign to temper our ambitions, or a stark reminder of the perils inherent in venturing into the unknown? Engineers took the tragedy to heart, refining their designs and safety protocols. They knew that soon, human lives would hang in the balance, and failure was not an option. The sacrifices of Lisichka and Chaika underscored the immense risks, but also propelled advancements that would safeguard future explorers. Amid these headline-making missions, countless smaller creatures played unsung roles. Throughout the late 1940s and 1950s, both superpowers sent mice, insects, and other small animals into space. These missions, though less publicized, were crucial. They aimed to unravel the mysteries of microgravity, cosmic radiation, and biological impacts on living organisms. Many of these tiny pioneers didn't survive, falling victim to technical failures or the harsh realities of the cosmic environment. Why did humanity persist in sending these creatures into peril? Was it an insatiable curiosity, a quest for supremacy, or a belief that the ends justified the means? Perhaps it was all of these, a complex tapestry of ambition, fear, and the relentless drive to explore. As philosopher Bertrand Russell aptly noted, the only thing that will redeem mankind is cooperation. Yet, in the fervor of the space race, competition often overshadowed collaboration. In December 1960, the Soviet Union launched Korabl Sputnik 3, also known as Sputnik 6. Aboard were dogs, Chelka and Mushka, along with mice, insects, plants, and cameras to document their journey. The mission aimed to simulate human spaceflight conditions more accurately than ever before. After 17 orbits, a malfunction during re-entry caused the capsule to deviate from its planned trajectory. The prospect of the spacecraft and its advanced technology landing outside Soviet territory posed a significant risk. Faced with this dilemma, officials made the harrowing decision to activate the self-destruct mechanism, sacrificing the lives of all aboard. Did this choice weigh heavily on their conscience, or was it deemed a necessary action in the high-stakes arena of global politics? The loss of Chelka and Mushka was a poignant reminder of the ethical complexities intertwined with scientific progress. Their sacrifice, however, was not in vain. The mission provided critical data that paved the way for Yuri Gagarin's historic flight just months later, when he became the first human to orbit Earth. The animal's journeys, fraught with peril and loss, laid the foundation for mankind's giant leaps into space. As we reflect on these narratives, we're confronted with profound moral questions. Were these sacrifices justified in the name of advancement? Did the benefits outweigh the costs? The stories of Albert II, Laika, Lisichka, Chaika, Chelka, Mushka, and countless others compel us to examine the price of progress. The important achievement of Apollo was demonstrating that humanity is not forever chained to this planet, mused Neil Armstrong, the first man to walk on the moon. Our visions go rather further than that, and our opportunities are unlimited. His words capture the essence of exploration, the boundless potential, and the drive to push beyond our limitations. Today, technological advancements have opened new horizons. Simulations, robotics, and sophisticated life support systems have reduced the need for animal testing. We can probe the depths of space with less risk to life, honoring the lessons learned from those early pioneers. Yet, the legacy of these animal astronauts endures. Their stories serve as both inspiration and caution. They remind us that the pursuit of knowledge carries responsibilities, that ethical considerations must guide our endeavors. As we set our sights on Mars and beyond, may we strive to balance ambition with compassion, innovation with integrity. That's one small step for man, one giant leap for mankind, declared Armstrong upon setting foot on the lunar surface. His iconic words symbolize not just a singular achievement, but the cumulative efforts and sacrifices that made such a moment possible. The silent journeys of these animals expanded the horizons of human possibility, urging us to reach for the stars while remembering the footsteps and paw prints that paved the way.
Lurking in the cosmic darkness are terrifying objects, each with the potential to obliterate our planet and extinguish all life. NASA should be on high alert. From rogue asteroids hurtling towards Earth at incredible speeds to cataclysmic solar flares that could fry our planet's electrical grid, the threats are real and imminent. First, we have Bennu, a near-Earth asteroid, has captured the attention of scientists due to its potential to impact Earth in the 22nd century. While the probability of a direct hit is relatively low, the sheer force of such an impact could have devastating consequences for our planet. To better understand this celestial body and assess its potential threat, NASA launched the OSIR-ISREX mission. This ambitious endeavor aimed to collect a sample of Bennu's surface material and return it to Earth. By analyzing this sample, scientists hope to gain valuable insights into the asteroid's composition, its formation, and the forces that influence its orbit. The data collected by OSIRIS-REx will help refine predictions about Bennu's future trajectory and the likelihood of an Earth impact. This information is crucial for developing potential mitigation strategies, such as deflecting the asteroid's path or preparing for a potential impact. Next is Apophis. This asteroid was once considered a significant threat, but further observations have ruled out an impact in the foreseeable future. However, it will make a close approach to Earth in 2029, providing scientists with a valuable opportunity to study it. This information will enhance our understanding of near-Earth objects and improve our ability to predict and potentially mitigate future threats. Our sun, while essential for life on Earth, can also unleash powerful bursts of energy known as solar flares. These massive explosions release intense radiation and charged particles into space. When a powerful solar flare erupts, it can disrupt Earth's magnetic field, leading to geomagnetic storms. These storms can have a significant impact on our technological infrastructure. Disruption of radio communications. Solar flares can interfere with radio signals, affecting everything from GPS systems to air traffic control. Damage to satellites. The intense radiation from solar flares can damage satellites in orbit, potentially leading to communication outages and disruptions to satellite-based services. Power grid failures. Geomagnetic storms can induce powerful electric currents in power grids, leading to blackouts and widespread power failures. Auroras. On the positive side, solar flares can create stunning auroras, or northern lights, as charged particles from the sun interact with Earth's atmosphere. While Earth's magnetic field provides some protection, severe solar storms can still have far-reaching consequences. Space weather forecasting has become increasingly important to mitigate the potential risks associated with solar flares and other space weather events. Rogue planets, the cosmic nomads. Rogue planets are celestial bodies that have been ejected from their original star systems, wandering the vast expanse of space untethered to any star. These cosmic nomads can range in size from gas giants to Earth-sized planets, and their existence challenges our traditional understanding of planetary systems. While the likelihood of a rogue planet directly colliding with Earth is extremely low due to the vastness of space, the potential consequences of such an event would be catastrophic. A massive rogue planet could disrupt the orbits of other celestial bodies in our solar system, potentially leading to catastrophic collisions. Scientists believe that rogue planets may form in various ways, including being ejected from their home systems during planetary formation or as a result of gravitational interactions with other celestial bodies. Despite their solitary nature, these wandering worlds could harbor conditions suitable for life, although the extreme temperatures and lack of a stable energy source would make it challenging for complex life to evolve. The study of rogue planets is a relatively new field of astronomy, and much remains to be learned about their origins, properties, and potential for hosting life. As our observational capabilities continue to improve, we may uncover more about these mysterious celestial objects and their place in the universe. Geomagnetic storms, a threat to our modern world. Geomagnetic storms, triggered by powerful solar flares, can have a significant impact on our modern, technology-dependent world. These storms can induce powerful electric currents in long-distance power lines, known as geomagnetically induced currents, GICS. GICs can overload transformers, causing them to overheat and fail. This can lead to widespread power outages, affecting millions of people. In severe cases, entire power grids can collapse, disrupting essential services like transportation, communication, and healthcare. The 1989 geomagnetic storm, one of the most powerful solar storms in recent history, caused a major blackout in Quebec, Canada. millions of people were left without power for several days, highlighting the vulnerability of our power infrastructure to these space weather events. To mitigate the risks posed by geomagnetic storms, scientists and engineers are working to develop technologies and strategies to protect our power grid. These include upgrading transformers, improving grid design, and implementing real-time monitoring systems to detect and respond to geomagnetic disturbances. Black holes, cosmic monsters. While the idea of a black hole consuming Earth might seem like science fiction, the gravitational influence of these celestial behemoths can have profound impacts on their surroundings. A close encounter with a black hole, even one that doesn't directly swallow our planet, could have catastrophic consequences. The intense gravitational pull of a black hole could disrupt the delicate balance of orbits within our solar system. Comets and asteroids could be flung out of their usual paths, increasing the risk of collisions with Earth. Additionally, the gravitational forces could alter Earth's orbit, potentially moving us closer or farther from the Sun, leading to drastic climate changes. Fortunately, the nearest supermassive black hole to Earth, Sagittarius A star, is relatively calm and stable. However, the vastness of the universe means that there are undoubtedly rogue black holes wandering the cosmos. While the chances of a close encounter are incredibly slim, it's a reminder of the immense and often unpredictable nature of the universe.